Hey everybody, welcome back. Today we're going to be doing the DC analysis of an NPN BJT. We have the given circuit to the left and we're finding the currents and voltages in the collector, emitter, and base. We're also going to find out whether or not this is an active transistor or not, because if it's not active, it will not be an amplifier. So there's really no point in solving for the small signal if it's not active. And what we really want from the DC analysis is to find the parameters. We have GM and R pi. As you guys know, R pi will be the resistance between the base and the emitter in the AC model. That's almost the whole reason that we're solving for this. Also important to note, VT is always going to be 25 millivolts and beta is always 100. This is the same for every circuit. It doesn't matter what circuit it is, every transistor. It's always going to be the same constants. So let's start off. Since we know it's an NPN, since the arrow is pointing out of the transistor, we know that VBE is going to be equal to 0.7 volts. That's always the same for all NPNs. VBE is going to be 0.7. What does this mean? It's the voltage difference between the base and the emitter. Now, if it was a PNP, it would be VEB equals 0.7, which would be VE minus VB. But in this case, it is an NPN. So first, what we can do is we can simply find two functions of VB and a function of VE. So how would we do that? Well, let's analyze the circuit. We see that VE is simply just going to be the resistance multiplied by the current. That would be IE multiplied by 3. And now we can see that for VB, it's going to be a little different. We have a more complicated circuit here. So the best way to do this would be to perform a KCL. So here we see that 15 minus VB over 3 equals IB plus VB over 9. Now that's KCL at node VB. So what we could simply do from here is we can isolate for VB, and once we do that, we obtain VB multiplied by 1 over 9 plus 1 over 3 equals 5 minus IB. So now that we have this equation, we can simply multiply both sides by whatever's in this bracket right here, and we obtain 2.22 minus 0.44 IB. Now, as you can see, we have VE and VB. VE is a function of IE, so we can simply just change that. Remember, you can write any current in terms of IC, IB, or IE. So we could simply write this as 3 multiplied by beta plus 1 IB. Because remember, IE equals beta IB. So now that we have this, we have one equation with only one variable, IB. So VB we see is, we plug both of these equations. We'll name this 1, we'll name this 2. We'll plug 1 and 2 back into our original equation. So we see that 0.7 equals 2.22 minus 0.44 IB minus VE, which is going to be negative 303 IB. Because remember, beta plus 1 is going to be equal to 101 since beta is 100. So using this equation to solve for IB, we can simply see that IB is equal to 5 times 10 to the negative 3 amps, or 5 milliamps. So now that we have IB, we can easily find IC and IE. IC is simply beta IB, and IE will be beta plus 1 IB. So once we multiply IB by 100, we get 0.5 amps. And once we multiply 5 milliamps by 101, we get 0.505 amps. So here we have the current in the base, the current in the collector, and the current in the emitter. Now, let's find the voltages. So using our given values, we can simply just write out formulas for each of them. So from our KCL that we found earlier, we know that VB is equal to 2.22 minus 0.44 IB. Now we could simply just plug in IB and we end up with, sorry about that, 2.21 volts. Remember, we plugged in 0.5 times 10 to the negative 3 amps for IB. Now for VE, it's simply just going to be IE multiplied by 3. So we can also write this as 0.505 multiplied by 3. VE, that gives us 1.52 volts. And VC, we can simply write this as 15 minus 9 IC. Now, IC we found was 0.5 amps, so 15 minus 9 times 0.5. Now, this simply just gives us 10.5 volts. Now, we have all our currents and all our voltages. We can find if it's active or not. So the first case, are the currents going in the proper way? Are all the currents positive? Yes, we saw all the currents were positive. All currents positive. Now the second case, VC has to be greater than VB. Now, what did we find here? We found VC is equal to 10.5. Now, is that greater than VB? VB is only 2.21. So yes, VC is greater than VB. We do have an active transistor. Now, for the final steps, we'll just find our parameters. So we know that GM equals IC over VT. And we found IC to be equal to 0.5. And we know that VT is always 25 millivolts. This is a constant, remember that. So we simply find this to be 20 ohm to the negative 1. And now we can find our pi. This will be used in the AC analysis. This is simply beta over GM, where beta is always equal to 100. And when we do this, we find that our pi is equal to 5 ohms. Thank you guys for watching, and I hope you guys learned something.